This problem offers quite a few more challenges. For starters, it's not equal to 0 from the get-go, so I need to get this. It'd be easier. It's always best to keep the squared term positive. But in this case, it's also easiest to subtract 6 from both sides, which does keep that squared term positive. So if I subtract this 6 and I subtract this 6, on this side of the equation, that has no like terms, so it's going to become the quadratic 5m squared plus 13m, then minus 6 equals 0. If you can get to this equation without showing this step, I totally don't mind at all. It's totally fine. Just be warned that a lot of times kids who think they can do it forget to change the sign on the 6, and then things do not work, because this is supposed to be factorable. This is going to be a tough one to factor too, by the way. I mean, we got a lead coefficient here, something other than 1. It's a 5. At least it's prime. So the only way to get to 5 m squared is with a 5m and a 5m and a m. But the 6 and 13, we got to be careful, because whatever we pop over here, whatever we put over here to give us 6, it's going to be 5 times whatever you put over there, and then the product of those to combine to make 13. So as I think about things that make 6, I mean, the games in town for 6 are 1 and 6. I don't want to put a 6 over here, because then I'll have a 30, and that 30 is way too far away from 13. So that's 1 and 6 is out, so it's probably 2 and 3. And if I just think ahead a little bit, if I put a 2 here, and a 3 here, a 2 here will give me a 10. Wait a second, is this going to be solvable? Oh, it is, but not the way I thought. Actually I thought it was going to be 2 here and 3 here, so I thought it would be 10 and 3, but that doesn't work. Let me show you why. If I put a 2 here and a 3 here, the outer ones make 10m, and the inner ones make 3m. I'm actually feeling pretty good about that, because those totally could combine to make 13. The problem is this 6 is negative, so these have to have opposing signs. And if these have opposing signs, there's no way I'm going to get to 13, right? It's not going to happen. But one of these has to be positive, one has to be negative. So I'm like, oh, teacher must have messed up. No, he didn't. But those are not the right places to put those. I hope I can erase these. So let's see if I can. So now I'll try instead with the 3 here and the 2 there. So now this outer product is going to be 15m, and that inner product is 2m. And the question becomes, if these have opposing signs, if one's positive and one's negative, can they make a positive 13? And they can, if the 15 is positive and if the 2 is negative. So where does the negative go? The negative goes on whichever one of these numbers made the 2m. I need the 2m to be negative. So the negative is here, and the positive is here. And this is an equation, so this still equals 0. And because it's an equation, I'm now going to take each portion of this and set it equal to 0 and solve it. So when does 5m minus 2 equal 0? That happens when 5m equals 2, or when m equals 2 over 5. When does m plus 3 equal 0? When m equals negative 3. So our two answers are 2/5 and negative 3. So just really quick, the steps: get one side to 0, factor it out, it's equal to 0, and anytime you're doing a problem and it equal to 0, then you set each factor equal to 0 and you solve.